Okay, this is a lesson on perimeters and areas of regular polygons. Now, regular polygons are polygons that have the same or congruent sides and angles. That's the only way these formulas work, is using regular polygons. So let's assume we have a hexagon here. A hexagon with, say, one side is 3 feet. We know it's a regular polygon. All the sides are equal, so we just take times 6. That gives us the perimeter of 18 feet. Now, when we want to figure the area of a regular polygon, what we're actually doing here, I'm going to give you the formula, but what we're actually doing is we are from the center of the polygon, we are cutting it into triangles. And then we are going to figure out the area of one triangle times all the triangles, because everything in a regular polygon, all these triangles will be the same or congruent triangles. Okay. So the area of a triangle is 1/2 base times height. Well, when we're doing the area for a regular polygon, we call the height something different. We call it the apothem, which is also the straight up and down altitude. So all three of these words mean the same thing. So the apothem is this line, which we have to have when we figure the area of a triangle, and it is a right angle here, or it's perpendicular. So when we want, if each one of these are 3, we can do the area of this triangle through this formula and get the area of the times 6 and the area of the whole triangle. They do a little bit of a shortcut here. They take 1/2. They do the height as the apothem, and then they times that times the perimeter, which would be the same as the perimeter is 18, which would be 3 6 times for 6 triangles. So this is the formula they use that you will use to get the area of your polygons. So this is A equals 1/2, and let's say this one is 8. Say the apothem is 8, and the perimeter is 18. And I think that ends up being, what's 18? And 8, let me do it real quick here, and divided by 2 is, this ends up being 72 feet squared for the area of this particular hexagon. Okay, that's all there is to it. Now, when you have a triangle, say you have an equilateral triangle, this equilateral triangle has all the same sides. It is congruent sides. It's a regular polygon. Start at the center and we break it into triangles. Well, here we go again. We have to look for the apothem, straight up and down height here. So let's say this triangle is 18 inches the whole side. Well, that means this one's going to be 9 and 9, right? Okay, well, let's look at this. If this is an equilateral triangle, the angles are all equal to 60. When we bisect them here, this one becomes 30 degrees. This is 90 degrees right here. and this one is 60. Okay, so now we have a 30, 60, 90 triangle. So when we have a 30, 60, 90 triangle, we have some special properties. We know that if this side is A, we know that this side is going to be A times the square root of 3, and we know that this side is going to be 2 times A. Okay, we learned this in a different chapter. It's a special property of a 30, 60, 90 triangle. So in that case, if we want to, we have to find A, don't we? We don't know what this is. But based on this, we should be able to determine what A is. So if this is 9, which this is equal to the A, which we don't know what it is, right? This is our straight up and down height here, our altitude here. A times the square root of 3. Okay, that's what this is equal to. Well, we can rearrange this, and we can get A by itself and determine that A is equal to 9 square root of 3. So that is what A is equal to. 9 over square root of 3. So we have to simplify this because we can't leave the square root of 3 on the bottom. That's not correct. And the way that we do that in algebra, we times it times the square root of 3 and times this times the square root of 3, and we end up with 9 square root of 3 over these two multiply and become 3, don't they? When you have a square root times a square root, it becomes 3. Then we can cancel these two out and make this 3. 3 goes into 9 3 times. So now we know A up here is 3 square root of 3. So once we have the A, okay, because you're going to have to use this format. You can't use this one. You have to use the correct format. Once we have A, we can take our formula, 1/2 times the apothem and the perimeter, right? For the area of this entire equilateral triangle. And that is A is equal to 1/2 times 3 square root of 3 times 18. This is 18. This is 18. That's 54. And then when we multiply that all out, we get 3 times 54, and divided by 1/2 is 81 square root of 3. 81 square root of 3. Okay, so that concludes lesson 66. This is lesson 66 on perimeters and areas of polygons. And I will be doing the practice problems for 65 and 66 on another video.